Hello, this is a demonstration of the Anritsu VectorStar ME7838A4 4-port 125 GHz broadband system. The system is comprised of the VectorStar, which in this case would operate up to 54 GHz in the broadband configuration, but when it's a standalone operation, it will operate up to 70 GHz. So in the broadband configuration at 54 GHz, it switches over to the millimeter wave modules, which provide the millimeter wave frequencies. So ports 1 and 2 are provided by the baseband VNA. Below that is the 4-port test set, which actually adds 2 more ports to this VectorStar VNA. So it provides ports 3 and 4 in the baseband frequencies. And so these 4 signals from the VectorStar and the MN4697C 4-port test set are provided to the millimeter wave modules and feed directly through the DC line to the DUT for measurements up to 54 GHz. Then, in order to go beyond 54 GHz, we have the millimeter wave test sets. So right below the 4-port test set, we have the millimeter wave test set, which operates and drives the ports 3 and 4 millimeter wave modules. So this is the 3736B millimeter wave test set, and then below that is the 3739C millimeter wave test set, which operates the millimeter wave modules for ports 1 and 2. And so you can see that we have our 4 millimeter wave modules, and I've labeled them for ports 1, 2, 3, and 4. And again, they're coming from the baseband VNA and the 4-port test set going to the module, and then switching over at 54 GHz, we have the RF and LO signals coming to the millimeter wave modules for operation up to 125 GHz. And so what we've also done is set it up so that we can do our coax calibrations, and that's when we'll use these coax calibrations standards as part of the 3656C calibration kit. And so we'll use these coax standards for the calibration when we perform that during the rest of this demonstration. And so now we can set up our system for the differential measurements. And first we'll set up the frequency, and we'll sweep from 70 kilohertz up to 110 gigahertz. The system goes to 125 gigahertz, but the cables we'll be testing later are limited to about 110. And then we'll set power, and we're set for minus 20 dBm. And now we can set up our response for differential measurements. And so typically at the top of the menu for response, we have our S parameters. And since we're going to go to differential measurements, we'll want to set that up for our differential mode. And that is selected in our mix mode menu. And so we can select that and configure for our differential measurements. And here is where we have the opportunity to configure the response. And so I've set it for 2 differential pairs. And then here we designate which trace we want to display and configure. And so let's say I go to trace 1. And so now that trace 1 is active, I can now designate. Now, in terms of our setup, we're just going to do differential pairing. And so for trace 1, we'll have D1, D1. And for trace 2, you see we have D1, D2. And then trace 3 is D2, D1. And then finally trace 4 is D2, D2. And then again, going back, so port 1 differential is combining the ports 1 and 3 of the system, and differential port 2 is combining the ports 2 and 4 of the system to give us our differential pairs. Okay, and so that's how we would set up this display, and that's what we're displaying here. And so next we would go to calibration in order to set up our calibration. And we just select calibrate, manual cal, 4-port cal. In order to show you how we configure the system and set it up properly for our calibration, we'll go to the modify cal setup. And then you see that we have our cal method selection first. And this gives us the opportunity to designate the type of calibration we want to do. And so there's a wide range of choices. For this coaxial calibration, we're going to select the broadband cal. And so that uses SOLT and then triple offset short for the millimeter wave frequencies. The final configuration step would be to edit the cal parameters. And so this is where we would designate the throughs that we are going to use. And so there's many different variations and selections available of the through pairings based on what is appropriate for your calibration. So in other words, in some cases for on-wafer measurements, there's a limitation on some of the through paths, and so you want to choose the paths that make sense or are achievable for the configuration. For this setup with these modules, we can go through these 4 selections, which is 1 through 2, 1 to 4, 2 to 3, and 3 to 4. And the key is that you need to include all of the ports, at least one selection of each of the ports that are configured and available. And then finally, what we do is define the throughs. And so, for instance, in this configuration, the through 1 to 2, we have it set up, as a through with a insertable connection. So I'll show you close up when we get down to the calibration. But what we have are ports 1 and 3 configured for male 1 millimeter test ports, and ports 2 and 4 configured for female test ports. And that will allow us to do insertable through calibrations. And therefore, the length is 0 and the loss is 0. Okay. Now, if we had to have cables connected to the modules, then we would give it a length, and the more accurate you can define that length, the more accurate things will become during calibration. Also, if you have an S2P file available for the through, you can designate the S2P file. And that's very useful for these kind of situations where you need to do de-embedding. And so if you have a test fixture that you have an S2P file, then you can select the S2P file for your fixture, and that will give you an added boost in performance during the calibration. So you see there's plenty of options here to configure your throughs and define your throughs. And in this case, we just enter the 0 and select OK. And you go through each of the throughs that you've selected and define them that way. Okay? And so next then is we define the test ports. Okay, so in this case, if you recall the test set that I was showing, we have a S2P file, I'm sorry, calibration standard coefficients. And you can see that in the cal kit, we have this USB drive that provides the calibration coefficients for these standards. And so we load that into our VNA, and then we point our standard information to that. So in this case, we have port 1. The DOT is going to be female because our test port is male, as we show here. And so this female standard needs to be defined, and we can go to our standard info, and here is where we have complete control on defining the standard. But you can see that in this case, we have the standard called up by that file, and so it's designating the serial number of the standard and giving you the information of each of those standards. And again, that's coming from the USB stick, which defines all the standards within that kit. Okay? And so again, we go through each of the 4 ports and define those standards before we start doing our calibration. So we click OK, and so that's where we're finished with our setup. We've defined the cal method, and then we've edited the calibration parameters to designate what standards we're going to be using. And so now we can start our calibration by selecting port 1 and then connect our coaxial standards to the test port. So here we have the setup for our 4-port measurements, and we have the 4 modules with 1 millimeter test port connectors, and we have the male on ports 1 and 3, and then we've added these adapters for ports 2 and 4 so that we have now an insertable through situation, which is why we configured our throughs to be 0 length. And so now we go back to where we were earlier, where the definitions of the standards are set up for our calibration, and we go to port 1 to start off with, and you see that we have requirements for our reflective devices, the open, shorts, and the loads. And so now we will start to add those standards to our test port in order to do our calibration. And so for port 1, we need an open connected. Next is our short. We want to make sure that we're always using our torque wrenches because it's important to have consistent torquing of our connectors, especially as we go up into higher frequencies. Now what I like to do is reconnect my test ports so now I'll go back to the calibration menu, and so you see all of my menus are selected. In other words, everything is complete and the done is now active. So clicking on done will then use all of the measurements I just entered into the calibration. Now that I have my 1, 2, and 3, 4 lines connected, I'm actually looking at the calibrated test ports directly connected together. One reason for doing this is it helps to confirm that the connection process and the calibration process was pretty reasonable. So like for instance, I've now zoomed in on ports 2 and 3, I'm sorry, on traces 2 and 3, D1, D2, and D2, D1, and I'm looking at the through connections. So if I had any kind of connector glitches in my system, I would pick that up now because it should look very good because I'm just looking at my standards. So you see I'm at 0.1 dB per division, and D1, D2 is under 0.05, well under 0.05, and D2, D1 is the same. And you can see the match of D1, D1 and D2, D2 is also quite good. If I go to my D1, D1, it's at 10 dB per. I can pull that up a little bit, and you see I'm down at 110, I'm 45 dB down. So, you know, this is telling me that the calibration is pretty reasonable. Now what I could do is connect a couple of coaxial lines between the ports to see how the calibration looks in terms of a very low loss insertion loss measurement. Okay, so disconnect my test ports, and again you want to be real careful not to break the connection between the adapter and the test ports, because that could certainly induce some connector glitches, or at least some variations due to connector repeatability. Okay. And so again, the scaling for the insertion loss measurement is 0.5 dB per division. And so in both cases we're at around minus 3.5 at 110 gigahertz. And you can see we're making a return loss measurement of the cable, and it's in the 20 dB range. This video provided an overview on how to set up and configure the VectorStar 4-port broadband system for differential calibrations. We focused on coaxial calibrations with a 1mm test port, and we use SOLT and triple offset short coaxial standards for the calibration process. If you need to do on-wafer calibrations using differential probes, then we have alternative calibration algorithms such as LRM and advanced LRM, where we can combine opens and shorts in the LRM calibration algorithm. There's a wide range of 4-port systems available from the VectorStar family, including frequencies up to 110, 125, 145, and even 220 gigahertz systems. There are different differential probes available, and very soon there will be a 220 gigahertz differential probe for differential on-wafer measurements up to 220 gigahertz. For more information on our different configurations and options available, please visit our website at anritsu.com. Thank you for your attention.